All right, let's keep the fun going with more limits of trig functions. So, limit as x approaches 0 of sine squared x over x. So, once again, we can manipulate these limits. I'm going to rewrite this as the limit as x approaches 0 of sine x over x multiplied by sine x. So remember, if properties of limit states if these two limits exist, I can separate it into two limits. The limit as x approaches 0 of sine x over x multiplied by the limit as x approaches 0 of sine x. Well, sine x over x, the limit as x approaches 0 is 1, and the limit as x approaches 0 of sine x is 0. So therefore, my overall limit is 0. In number 4, I could break this up into two limits, but it would then give me infinity minus infinity, which is an indeterminate form. So when I get an indeterminate form, or if I just plugged in 0, I would get 0 over 0, which is an indeterminate form. So when that happens, you should be thinking manipulating. How do I manipulate something that looks like this? Well, 1 minus cosine x, I can play around with its conjugate, 1 plus cosine x. So think about manipulation of rational expressions are conjugates for radicals and for trig functions. So this becomes the limit as x approaches 0. This becomes 1 minus cosine squared x on my numerator, and this becomes sine x 1 plus cosine x on my denominator. So remember our Pythagorean trig identity, 1 minus cosine squared x is sine squared x and then I see that my sine x's will cancel, and I'm left with the limit as x approaches 0 of sine x over 1 plus cosine x. Now at this point, I can just do direct substitution. If I plug in 0 into my numerator, I get 0, and I get 1 plus 1 on my denominator. 0 over 2 is 0. So that is my limit. After I got an indeterminate form, I simplified my rational expression by multiplying by the conjugate. I used my trig identity to simplify and then did direct substitution.